So welcome everybody to today's presentation on Bridging the Gap, BIM for Facilities Management. So a little bit about me. I'll be your presenter today. I'm the Director of Asset Management, George Broadbent. And you know, my background is mostly in information architecture. I've been dealing with enterprise asset management now for 25 years. But really, when I look at all these different issues that circulate around BIM, around facilities management, to me, it comes down to what's the information that's being handled, how is it being handled, and are we dealing with it in the most efficient manner possible? In terms of our asset management engagements that we've done across the country, we're showing you here a few who's. That's California, Nevada, Clark County, Denver International Airport, Massachusetts, the Massport system there. New York, we've got quite a few customers there as well. All these customers have one thing in common, that we're supporting them in terms of asset management engagements. We're using with the latest technologies to address operational issues using BIM and understanding the strategic impact that BIM has on facilities operations. What we're talking about today is bridging the gap between BIM for facilities management and how do we go from a BIM model, a 3D model, into facilities management, and why do we need to do this? So let's start off with just a quick definition of what is asset and facilities management, because a lot of times those terms get interchanged. And what we're dealing with is the asset management. An asset management system is, as you see here in the definition, systematic and coordinated activities and practices through which an organization optimally and sustainably manages its equipment and the related systems, as well as the related performance, risks, and expenditures over the life cycle, and achieving, the purpose is to achieve the organization's strategic plan. Okay, so that's asset management. But when you look at the definition for facilities management, it's the integration of processes within an organization for operations, maintenance, and development of the buildings or properties to support and improve the organization's strategic plan by integrating people, systems, places, processes, and technology. So what we see here is that both the asset management and the facilities management have very similar characteristics. And really, they're common goals for the organization. So even though these are very different practices, they all fall under operations. And that's really how we're going to address these going forward throughout the presentation. We're all going to put this into the context of operations and see how we can work with this. So what are the drivers for today's facilities and asset management systems? What we see is that you have organizations that are looking at the ISO standards to ensure that organizations follow its best practices. The adoption of the Internet of Things is growing rapidly to allow organizations to adjust to the approach to operations based upon equipment feedback. Mobility is quickly becoming the primary interface for enterprise applications. And then advanced analytics allow the organizations to ask questions and get answers about the state of operations like never before. And that's really kind of the key thing, is to be able to get answers about the operations. Because before you could ask all the questions you wanted, but there was never really the data there to support the answers. And then finally, all of this comes under the umbrella of corporate and social responsibility. And this is all certainly a driver. These are all drivers really for the facilities and the asset management practices that are in place today. Now, in terms of the ISO standards, we're not really going to talk too much about ISO standards today, but just really kind of give you a framework for how, at the top level of the organization, they're looking at that operations, facilities, and asset management. So like I said before, that ISO standards are growing in popularity amongst organizations that want to adhere to the best practices in the industry. While we're going to see from this graphic that we're talking about asset governance, We're talking about how ISO 55K makes asset management an organizational priority, and then common data formats are critical to its success. Really, in any of these things that we're talking about, the data consistency is really a primary driver for this information, for how these systems get implemented. So what are the benefits of putting in an ISO 55K compliant system? So the best of breed companies out there will have these kind of measurable results. 2% of unscheduled asset downtime, that's a pretty admirable metric to achieve. The tactical versus reactionary ratio, meaning that you are planning all of your work and you're not in emergency response. That means 90% of your time is in planning, and only 10% of your time is spent reacting or reacting to unexpected events. This results in a 30% reduction in maintenance cost, 20% return on asset versus plan, and then 3% revenue loss from risk events, meaning that for all of those emergency events that you have, even though you're having an emergency, you're minimizing how much you're losing. So cost control means stability for an organization. That's really what it comes down to. So this is, this is really where we start to get into how do we achieve these goals. If you want to become an organization that achieves the numbers like we saw before, then really the fundamental starting point of all of this is the data. Without having reliable and consistent data, you can't achieve, well, first of all, you can't measure what your performance is, and then second, you can't achieve these kind of goals that the ISO standards lays out for us. This is where BIM comes in and really becomes a game changer for the organizations. So why are we doing this? Why is it building information management, BIM? Why is it that we want BIM in operations? So BIM gives us the ability to have the data consistency that the organizations need. Our own studies with clients have shown that we've found that the combination of BIM and facilities management achieve a net 5% saving in annual operations expenditures. And we'll look at some of the details on these numbers later on, but the idea is that by maintaining BIM models throughout the life cycle of the facility, combining that information with your FM system, and then the operational efficiencies that are achieved by having the two systems combined, then we showed a net 5% savings in operations. And what we're seeing as a growing trend across organizations is that the BIM process is really now a part of operations. And over the next 5 years, what we see, and we predicted that BIM will really become a critical part of the operations. So BIM is now being used within operations, but over the next 5 years, really it becomes something that they can't do without. And then how do we represent this? Typically, we look at this as a linear timeline where we go from post-design, construction coordination, a commissioning process, as-builting, there's a data transition period, and then into operations and maintenance. This is sort of the typical linear look at how data moves from your design all the way through operations and maintenance. However, the BIM process, the data and the deliverables that are derived from the construction process in BIM is needed. And how is it needed? In that the BIM data itself, meaning that I have a piece of equipment, I know a make, model, manufacturer, a serial number. This is all useful information for operations. The data that's captured during construction is needed in operations, in that, we want to know who's got the warranty information, how long is the warranty period for, what's the extended warranty information. This is all information that's captured during the construction process, and the operations groups need this information. And then 100% of the 3D models and the floor plans are needed in operations. This is, anybody in operations will tell you this is the case. And so really what we're looking at now is the data transition process. And when we look at this in this sort of linear timeline here, really the linchpin in all of this is the data transition period. It's the link between your as-built models and your operations and maintenance. So what does the typical timeline for data transition look like? We have, on day one, the end of construction, which is also corresponds with the start of operations. So end of major construction, our operations group is going to start to take over the facility and start to perform maintenance and checking on equipment, answering calls, looking at heating issues, looking at how the facility is performing. But all the while, the deliverable is being prepared by the general contractor. So at some point after operations start, they have prepared the operations and maintenance manuals, the cut sheets, equipment lists, warranty information, and then some period after that, there's a construction closeout, which is typically, I'm going to deliver the information, and we're going to take care of all the financial closeout. There's punch lists that are being developed during this period as well, and then the contractors are going to be dealing with those last-minute punch list information. But all the while, the facilities are performing operations and taking care of the facility. At about 18 months, we have the operational data delivery, meaning, and some organizations have said that this number is closer to 12 months, and some have told us that this number is closer to 30 months. So 18 months is sort of a sweet spot for organizations where they receive the data that was prepared by the general contractor. Sometimes that's all paper, as you can see in the photo here, where you have boxes and buckets of paper that's being delivered. Sometimes, if you're lucky, you get DVDs of this information that go along with it. But the key is that the operations group now needs to sort through that information, find the information that they need, put the information into an operational system, and start to manage the assets. But what's happening during that 18 months of that data transition period? So the maintenance staff is going to go out. They're going to survey the facility. They're going to obtain the operations and maintenance manuals from the manufacturers on their own. So they can go and look at the equipment. They can see what what make, model, serial number is on the equipment, and then go to the website, download the O&M manual. They're going to develop their preventive maintenance routines. And here's the critical one here. They're going to replace the equipment that has failed. Time and time again, I have talked to organizations where they are replacing equipment that is under warranty and or under an extended warranty. So during the construction process, many organizations are very proactive, and they say, we want to have extended warranty on our critical pieces of equipment. However, the information about the warranty typically doesn't make it down to the operations staff, at least not for at least 18 months. And so when that piece of equipment fails, they're responsible for making sure that the facility is operational. They go out and they replace it. Now, but let's actually look at this as a cycle where BIM is really at the center of that cycle. This methodology here, this process applies to both new facilities and renovations. The data transition period that you'll see in here is really the linchpin between the asset commissioning and the maintenance and operations. And really the key is to no longer leave that data transition period up to the projects. So before I was talking about the ISO standards and how asset management is elevated to a higher level within the organization. And really what we're talking about now is taking that data transition period and making it a part of that higher level within the organization. In other words, don't put the data transition period inside the project. Make it a requirement that's outside the project so you can ensure consistency of data transition, so you can ensure that the right data is getting migrated and that operations gets a consistent amount of data. Again, consistency in the data that we're dealing with will ensure that you can go and work on the ISO standards and trying to achieve those various metrics that we looked at earlier. So what is the data transition? It's a software package that we call Model Stream, and then in the operations and maintenance we call IBM Maximo. So we had done a webinar a number of months back that was talking about how we would use this software called Model Stream, which is our own software, that would allow us to move the data between Revit and IBM Maximo, and then from Maximo back into Revit. It's a seamless bidirectional transfer of information between the two systems. And really what the Model Stream software will allow us to do is look at how the Maximo assets are created, the location hierarchy is created, asset attachments and links, they're transferred over from the Revit model. And again, it's bidirectional synchronization of information between the assets and Maximo and Revit. So by having the Model Stream piece in there, which is the technology of the data transition period, now we're able to ensure that the operations has the information that it needs starting on day one of operations. And again, I'll show you some details as to how exactly that happens. So how do we get there? So the as-built process itself is, again, that's another one of those transition periods that we talked about before. We have to change the way we look at the as-built process a little bit. The typical 3D BIM models are very homogeneous. You know, there's one level of detail that's typically applied to the entire model, and so you would have, you know, an architecturally LOD 400, 500 model with all of the details in it applied to every single piece of equipment. But operations doesn't necessarily need this level of graphical detail on every single piece of equipment. So what we're talking about here is actually having varying levels of level of detail throughout the model based upon the function of the assets. So for example, like an HVAC system, you know, you may want to represent the air handling units as just a box. And then, but a valve, you might want to have a high level of detail on the valve, graphical detail, so that you can understand how the different connections are working on that valve and where exactly it's located. So we call this a composite BIM model that we would use for the operations group. And then what does this typically look like? And so you'll see these in these pictures here. This is how we would integrate BIM and facilities management. And what you're seeing in the picture is that this is not what you would call your typical Revit model in the picture on the right-hand side here. This is a very lightweight model that you can use on a tablet. You can use pinch and zoom. You can use your hands to navigate through the model. And when you click on elements, then you would start to see the details for the element itself. And this is a great way of introducing 3D models to your operations group, because it allows them to be to get more comfortable with how to interact with a 3D model versus having to learn software such as Revit and then navigate through the 3D model. So again, you can use, pinch and zoom. You can use your fingers to spin around the model. You can search for information. Gives you all of the information at your fingertips. Now, as you drill into it, though, you start to see, we zoom in and we start to look at, okay, we've got some pretty big blocks here that are representing different pieces of equipment. So again, that level of detail that's needed is shown, but the key thing here is also that we have all of the data associated with that piece of equipment embedded within this lightweight 3D model. And then again, you drill in even further to the model, and now you start to see specific details that are highly accurate. For example, a valve that's shown here. What's critical to operations is a number of different items that are represented from this model. One is the placement of the valve. Where physically is that valve? So that's number one. Second is, what is this pipe that's connecting to the valve, and what's this pipe that's leaving the valve? In many cases, when you have a valve and there are two different types of material, one entering and one exiting, those are points of failure for an operations. And what you want to try and do is minimize the number of round trips that operations needs to make to the site where they have to do a repair. So if operations is able to look at and say, well, this is a copper pipe, and it wouldn't be in this picture here, but if one side of the valve was a copper pipe and then one side of the valve was a plastic pipe, then I know the size of the piping, then I can bring those pipes with me and effect a repair. Or I can bring the repair kit for that type of piping out with me. But I know the information about what it is that I'm going to be dealing with before I get to the place where I have to do the work. And that's really, that's part of the critical element that actually drives down the operations costs. Because way too often times, depending on if you have a campus, for example, traveling to an area where something needs to be repaired and back again, you might spend, 2 hours just going back and forth, trying to find out what the right piece of equipment is. Or trying to identify, do I need a ladder? Do I need a 12-foot ladder with me, or is a 6-foot ladder okay? Again, the Revit model, the BIM model, can give us all that information, and we can very easily make it available to the operations staff in this lightweight format. So when you start to bring it all together and you start to look at how the construction execution process works, you look at, this is just another sort of expanded view of that little timeline that I showed before. So we have, planning, pre-construction, construction, commissioning, the post-construction process, and the operations and maintenance process. And in through this, we break this down typically into 4 phases. We have an information strategy, an information capture, an information transfer, and then into operations. So there's a data management, which we call the BIM for FM guidelines, which occurs in the planning piece. And again, BIM for FM guidelines is really just sort of a way of saying that we're going to look at what the end state is and ensure that the BIM guidelines has the end state in mind. There is a submittal management systems that are typically used throughout this entire phase 2 process. And then in phase 2, we use the BIM 360 components to manage all the information. And then in the post-construction and the operations world, That's where we would use model stream going into Maximo. And then Revit is sort of the underlying technology that connects all these pieces together. And then there's the as-built process, a data extraction process, and then throughout the entire process, we're talking about analysis and reporting. So what are some of the key components here? Which is one, having Revit available throughout the entire process. BIM 360 is used, and BIM 360 will connect in with the Revit system. Model Stream connects the Revit system into Maximo. And really what we're talking about here is making sure that the data, the information that you're handling throughout the construction and operations process is handled electronically. Now we can't ensure that 100% of the data is going to be electronic, but we can come pretty darn close with this process. And the idea is that if you are handling the data electronically, then you reduce obviously you reduce the manual data entry, but you also reduce the errors that occur from manual data entry. So again, we use systems and rules to make sure the data transfers from one place to the other, and thus reducing costs across the entire process. So let's get into some of the nitty-gritty use cases here and how this all works together. So in this example here, we combined the BIM process with the facilities process. And we looked at a number of different examples with some customers. So the first one was a plumbing leak. Again, a fairly typical and unfortunately frequent occurrence within an organization. The next one is a shutdown request, which is very typical in a hospital, that it's a time-consuming and lengthy process that needs a lot of information available for it. Same thing with structural and fire safety analysis. Again, finding the right information at the right time about the, are there firewalls in place? What's the rating of the rooms and so forth. The integrated finish schedule. What's the color of the paint in the room? Again, seems like a fairly mundane use case, but you'll be surprised to see exactly how much time is spent looking for paint schedules. Engineering staff training, again, you get a new person joining the operations group. How do they become familiar with the facility and the operations? And then asset information entry and update, what's needed and how is that going to occur. So these examples are organized in order of frequency. So the plumbing leaks are the most frequent, asset information entry and update is the least frequent. And here's the results of what it looks like. So the plumbing leak, again, it's the first column is going to show us what the baseline looks like without BIM. And then we're going to look at the hours with the BIM and then the net savings. So the baseline hours without BIM, plumbing leak, you say, okay, it's 2.5 hours to resolve a plumbing leak. Doesn't sound like it's all that terrible. The hours with BIM, however, it's down to 3/4 of an hour. So you save, just shy of 2 hours on each event. And again, these were organized by the most frequent down to the least frequent. So if you're dealing with 10, 15 plumbing leaks in a given month, now all of a sudden you're dealing with half of somebody's time for a week. And that is sort of a major distraction, if you will, for the operations group, having to research the information, find the information, identify where it is, and bring the correct piece of equipment out, which is what consumes most of the time for the baseline hours without BIM. The shutdown request, I like this example a lot because the amount of time that it would take to do a shutdown request was reduced by 40 hours, as you can see. But really, the majority of the time that was spent, the 56 hours, was working with an electrical contractor, tracing out the the circuits. And so you have not only the cost of the electrical contractor, but you have the maintenance staff that needs to work with them, and then the time it takes to trace the lines and document the lines. Again, a BIM model can handle all of the systems, and so if you define your circuits, at least you can identify what rooms are affected by the circuits, and then the time spent tracing the circuits or verifying the circuits is reduced down to about 16 hours. The structural and fire safety analysis, again, another thing that's important to hospital facilities. The 3 hours would have normally have been spent doing a site survey, popping ceiling tiles, looking above the ceiling, seeing if the walls are extended up or not, looking at the rating of the drywall that's in place. Again, all this information is at their fingertips by having the BIM model integrated with their operation system, and they're able to save about 2.5 hours off of each one of those events. Another one of my favorites here is the integrated finish schedule. Typically the integrated finish schedules are not known within operations unless you make a concerted effort to really start to go out and record the information that's needed. But many times what they'll do is they'll actually just have to take a sample off the wall, go down to the paint store, get the color matched, get some paint, make sure that, verify that it matches what the finish is supposed to look like, and then get the contractor in to do the painting. Now, the 32 hours with BIM is really mostly like, okay, I'm going to look it up, and now I'm going to just deal with the contractor to coordinate when it is they come in and how much paint do they need to be painting. So there's a massive amount of savings that was done using the integrated finish schedules. And if you deal with any organizations that have set color schemes, these kind of savings are tremendously important to them. Engineering staff training, again, this is where organizations would typically have somebody following the maintenance staff around for 2+ months, going out with them, looking over their shoulder, and just following them around. And what we're able to do here is give them about 8 hours with the BIM model and look at how to navigate through the facility. Okay, and where is the equipment located? And then they would spend about 8 hours shadowing somebody on their maintenance runs, looking at what they're doing, how they're doing it, understanding the procedures, and then about another 4, 5, 6 hours in there, again, doing a combination of the two, looking at the BIM model, shadowing somebody, and they said with the BIM model incorporated into their operation systems, they were able to greatly reduce the amount of staff training time that was needed. Again, you'll see here, 178 hours. Asset information entry and update, again, at the end of that 18-month period, when all that data comes in, typically you would have, what's represented here is, almost 1 man year of data entry that would be done. So they would have people rotating in and out to do data entry. So the key here is that, when they're doing the data entry, they can't be doing preventive maintenance, they can't be working on operations, and so it becomes really a distraction to what they're doing. So again, these are organized by the most frequent to the least frequent. So again, asset information entry and update, you're going to do that once in a year, but it's going to take you all year long to do that work. Engineering staff training, maybe you'll hire 1 person, 2 people in an entire year. Integrated finish schedules, repainting occurs once a month, maybe. Structural fire safety analysis, these requests come in, several times a month. The shutdown requests, again, a couple of times a month, these things are happening here, and plumbing leaks are 10 to 15 times a month. So let's start to, again, tie all these pieces together into some real-world scenarios. In a couple of the customers that we worked with here for the new construction on the Goethals Bridge, there was an analysis of the design model that was done. We implemented the structural member naming convention on this is all within the Revit model itself. And then we migrated those assets, the structural assets, from the Revit model into Maximo using Model Stream. And then we implemented the model viewer within Maximo. In total, that whole time was about 4 weeks to complete the entire project, which is really critical because when they go out now and do their inspections or they look at the structural members on the bridge, they can not only track the individual members and their conditions, but when they're out there, when they're looking for like tracking defects or tracking maintenance that's being done, they can start to look at the entire bridge and pinpoint where those maintenance activities are occurring. Denver International Airport, in terms of when renovation work is being done, so Model Stream is being used by them to synchronize their real-world conditions. So what they're able to do is extract a section from a master facility model, hand that off to a renovation design team, do the renovation work itself, and then incorporate that new section of the facility model back into their master facility model, and then migrate all the data, the new data, back into their Maximo system. And what this is doing for them is it's allowing them to pull data out of Maximo, place it into the Revit model. So now the real-world conditions are represented within the Revit model, and then hand that off to their design team. And then when, again, a post-construction world, a post-renovation world, they're able to then take that new data and bring it back into their Maximo system, so that at the end of the renovation period, the operations has the most current and available information to them. So again, the goal, we're talking about as-built modeling here. We're talking about composite models. These different models, these facility models, it has all different kinds of names or connotations associated with it. But really, the key thing is now we have a record model. Okay, we have something that's relevant for the life of the facility. It's not just a snapshot in time. It's something that is available for the entire life of the facility and is up to date across the entire life of the facility.